water into a mixture of gases. This presentation is for information purposes only and must not under any circumstances be considered to be an encouragement that you should construct anything based on this information. Your actions are your responsibility and yours alone. HHO is a common name given to the gas mixture produced during the electrolysis of water. Electrolysis can be accomplished by placing two conducting electrodes in water and applying a suitable voltage to those electrodes. The illustration here shows the general principle. You have a battery connected to one electrode and the negative line connected to the other electrode, and they're both placed in a container of water. The result of doing that is bubbles of gas leaving the liquid. The volume of water doesn't appear to change much because 1 litre of water produces around 1,750 litres of gas. Michael Faraday did this and determined how much gas was produced per amp of current flowing between the electrodes. Scientists assume that Faraday's results are the final word on the subject. They aren't. Bob Boyce of America does not consider an electrolysis cell to be ready for use until it exceeds twice the performance of Faraday's experiments. We have a problem with the above arrangement. The voltage which produces gas from water is 1.24 volts, and so if we apply, say, 12 volts to the electrodes, then that is very inefficient. 1.24 volts produces gas, 10.76 volts produces heat and nothing else. The heat is not generally useful. So that overall system is only 10% efficient, and 90% of the power supplied to the system only heats the water. We can improve the arrangement by using two cells connected in series, that is, in a daisy chain. This doubles the amount of gas produced, and it doubles the overall performance of the system. Here 2.48 volts are used to make gas, and 9.52 volts are making just heat and are wasted in making heat. Of course, we could use 3 pairs of electrodes to raise the efficiency even further, and that's a considerable improvement. Now we're getting 3 times as much gas and less power wasted heating the water. Experience has shown that using 6 or 7 pairs of electrodes with a vehicle's electric system is the most effective combination. However, water does not easily break down into HHO gas, and so using a catalyst is an important step forward. The 2 best known true catalysts are sodium hydroxide, NaOH, and potassium hydroxide, KOH. These increase the current flow through the water, and so increases the HHO gas volume produced. The optimum sodium hydroxide mix is 20% by weight, and for potassium hydroxide 28% by weight. However, those catalysts react with many electrode materials, and so 316L grade stainless steel has found to be a good choice for the electrodes. It's not realistic to use the electrode arrangement shown already, as sufficient space is not available in vehicles. Instead, all electrode pairs are placed inside one container. As seen from the top here, you have 1, 2, 3, 4, 5, 6 cells connected in a row with the battery across them. Seen from the side, you can see the battery connections are made at each end, and there's a jumper wire between each of the pairs of electrode plates. That arrangement will certainly work, but it's not as efficient as it could be, and this is why. You've got wasted space between the metal plates, you've got a wasted plate between every 2 bodies of electrolyte, and a wasted wire connecting those two plates. So although some people find it difficult to see the difference, the common method of setting up an electrolyzer is plate, electrolyte, plate, electrolyte, plate, electrolyte along the length of the electrolyzer itself. Now, for that to be effective, the plates have to be embedded securely into both the sides of the case and the base of the case. Now, the gap between the electrodes is important because the smaller the gap, the more gas is produced. But the smaller the gap, the harder it is for gas bubbles to escape. So 3 millimeters between the electrode plates is considered to be a good spacing. That means that the case is really not all that large. Adding HHO gas to the air entering an engine is highly beneficial, as it promotes the full burning of the fuel being used, and that offsets the need for a catalytic converter, as well as increasing the miles per gallon from anything from 20% to 100%, and only half of 1 litre per minute of HHO flow is needed to do that. Some people are afraid of HHO gas as they think that it can explode. It can't. Water expands some 1750 times to make HHO gas, and so if it ignites and returns to water, then it will be some 1750 times smaller. That is, it implodes. That change in size is very fast, and it releases a good deal of heat. A word of warning here: do not ignite HHO gas in open air, as the bang is so loud that you could damage your hearing and be deaf for the rest of your life. A very important device for working with HHO is the bubbler. The bubbler is a very simple device. It's a container filled with water. You want at least 5 inches of water above the tube through which the gas is fed into the system. Holes along the bottom edge let lots of little bubbles of HHO escape and float upwards to the surface. There's a baffle there to prevent splashing getting into the output gas pipe. The idea is to have a large block of water to prevent any accidental ignition of the gas from passing through. You don't want the ignition to go through the water, so the water stops the ignition and is the only really effective way of blocking a flame front passing through HHO gas. It's helpful to have a large number of small bubbles rather than a few large bubbles. The fact that HHO implodes leaves us with 2 options. The first option is to change the spark timing drastically and make the implosion suck the piston upwards on what used to be the compression stroke. This isn't convenient, although it has been done successfully, in spite of the valve operation changes needed. The second option is to change the implosion into an explosion, which is a good deal easier than it sounds. The trick is to use the heat of the implosion to turn water into steam. And the fastest way to do that is to add cold water mist or fog to the incoming air. That results in flash steam, which provides a positive pressure on the pistons, as the normal fuel would do anyway. That means that you can run a generator of this general type without using any form of fuel, be it petrol or diesel. Further, you can avoid having to alter the timing of the generator if you choose to bubble the HHO gas through acetone before feeding it to the engine. David Quarry of New Zealand prefers to use an adjustable mixture of ordinary HHO and acetone treated HHO, as shown here. You have the electrolyzer, which generates the HHO. You have a safety bubbler filled with water. The gas coming out of the bubbler is split into 2. One goes through a flashback arrestor and a gas flow rate valve control in the rate of flow through this particular pipe. The other part of the output goes through a non-return valve and through a second bubbler which is filled with acetone, and that output then goes through also a flashback arrestor and a gas flow rate control valve. The two pipes join together to give a gas mixture which is controllable in the ratio of untreated HHO and acetone treated HHO, and that's a pretty versatile system in itself. However, leaving those details aside for the moment, and while using DC electrolysis for use with a generator or a booster, the gas output can be improved quite readily. The first step is to use an ordinary pulsing circuit instead of just a battery or car electric supply. These pulsing circuits are sold as DC motor speed controllers. They can look like this, which is a small circuit board and a large heatsink attached to a transistor, and a variable resistor used to adjust the speed of the pulses. The unit shown here is intended to provide up to 30 amps, and fancier units are also available. Bob Boyce is the most experienced person in the HHO field, and he stresses the necessity for careful preparation of electrodes before you start using them. For this, the 316L grade of stainless steel electrode plates have all traces of oil, grease or other contaminants removed from them, and then they're sanded with grade 80 sandpaper in two directions which are 90 degrees apart. The reason for doing this is to create tiny peaks on both surfaces of every plate. The first sanding direction is in one direction only. The second sanding direction is in one direction only. When that's been done, the plates are washed with distilled water, and all hand contact is avoided by using disposable gloves. Next comes the conditioning process, where the plates are inserted into the electrolyzer and current run through the whole set of plates for several hours using a 20% sodium hydroxide electrolyte, and it's important to use only sodium hydroxide for this particular process. The plates are then rinsed off with distilled water, and the process repeated until the electrolyzer performance is at least double that of Michael Faraday. More precise details for this process are given in Chapter 10 of an ebook which is a free download and is available from www.free-energy-info.com / PJK lowercase book.pdf. That is a very useful and large ebook which provides a major amount of information on not only HHO but a lot of other free energy processes as well. The rate of gas production can be increased, obviously, by increasing the number of plates in the electrolyzer. Now, if you're going to do that, you need to increase the voltage as well. Bob Boyce chooses to do it this way. He increases the size of the housing holding the electrolyzer plates and puts all 101 plates to create 100 cells in one single straight line. He then feeds it with higher voltage. He gets the higher voltage from a 12-volt battery going through an inverter, and as he's in America it would be a 110-volt inverter. That gives 110-volt root mean square alternating current, which is then rectified by these four diodes forming a diode bridge to give 155 volts of pulsing DC. The arrangement that's shown here is very effective. Bob prefers to use plate sizes of 6 inches by 6 inches, or 150 millimeters by 150 millimeters. The DC efficiency of each cell is approximately 216% that of Michael Faraday. The next step forward in this process is by drawing energy in from the environment, and Bob has developed a circuit which does that, and the result is a further 5 or 6 times the HHO output, making the result a minimum of 1000% better than Faraday's efficiency. That is 10 times Faraday's output, which shows how ineffective his definition of what is the optimum output from electrolyzing water. This circuit which Bob designed uses a toroid. It's an iron dust core toroid because iron dust, when encased in epoxy, is able to go to high frequencies. This 6.5-inch diameter toroid is connected like this in a circuit. The circuit is actually quite straightforward. You have initially a vehicle electrics or battery which goes through a circuit breaker for safety, through a gas pressure switch which will disconnect it if the pressure inside the electrolyzer rises too much, then through a relay which is capable of handling 20 amps, and it passes then as something around 13.8 volts DC into his 110 volt AC inverter. That generates 155 volts of DC when it's rectified by this diode bridge. That is smoothed by two 450 microfarad 200 volt capacitors. That then is effectively a high voltage DC supply. That's fed through a heavy choke which blocks any ripple peaks that are coming to the electrolyzer, and through another heavy duty choke which blocks any random peaks through the secondary coil which is wound around the toroid and on to the electrolyzer. Now, just a warning about this. The electrolyzer forms the load for this circuit, but it is also a safety device, because if the arrangement that is produced in this toroid starts to run away, the additional power is fed to the electrolyzer, and all it does is increase the rate of converting water to HHO gas. The system is very effective, and it gives a very large output. In Bob's case, he can get up to 100 litres of HHO gas per minute from his system. Now, the key part of this circuit is a very carefully wound toroid using specific materials, and the electronics board which drives the toroid. It's essential to wind the toroid very accurately as described in the ebook, and you use solid core copper wire which is coated with silver before it's insulated with plastic. The toroid is wound like this, as shown here. The secondary winding is made first, and it's a counterclockwise winding around the toroid, and it's also counterclockwise winding direction of the wire. That is, the wire starts off and goes over the top of the toroid, down through the hole in the center, and back underneath the toroid to come up to form the next turn of this particular coil. Now, you need to have the coil turns very accurately positioned and spaced, so the gaps between every wire turn on the outside of the toroid should be identical to the one beside it. The winding of this is described by Bob Boyce as needing to be better than military grade quality. This particular secondary winding is covered with tightly stretched PVC tape to form a good base for the primary windings which are going to be wound on top of it. There are 3 counterclockwise wound primary windings positioned as shown here. As you can see, they're equally spaced around the toroid. I understand that frequently you get 47 turns in each of these windings, but the number of turns is not that critical. The importance is to have them wound very accurately and tightly, and when they are finished, the windings are held in place with beeswax before being tightly wound with tape, PVC tape, and the finished toroid is placed in a metal Faraday cage to cut down any transmission from the toroid itself when it's been powered up. So that is the way that the toroid is actually wound. Now each of the windings, primary windings on that toroid, are fed their own individual signal. It's not shown specifically in this diagram, but each of these comes out to a different winding on the toroid. These are 6 very simple circuits. The circuits are NE555 timer chip circuits. The first one runs at 42,800 cycles per second. It's produced by using a 100k resistor and a 10 nanofarad capacitor in the 555 circuit. The middle one runs at 21,400 cycles a second, and the 555 circuit uses a 100k resistor and a 22 nanofarad capacitor. And the third one runs at 10,700 cycles per second. It uses a 100k resistor in the circuit and a 47 nanofarad capacitor. Now you might think that it'd be more sensible just to use a divide by 2 circuit to get this signal, and another divide by 2 circuit to get this signal. But that's, while it does work, it's not nearly as good. It's better to have these free running, because the components that you use to build them are usually not quite accurate, and as a result you get a heterodyning result from the outputs being combined. That is, that they build up like a dangerous random wave that you get in oceans from time to time. Now each of these signals is passed through a variable frequency gate, which is a system that blocks the signal off for a time, then lets it through for a time. Now that arrangement is very effective, and it gives you pulsed outputs. Now the outputs do not match each other perfectly. Now that means that the windings on your toroid are not all powered up at the same moment. They can be, but they aren't generally. And that is more effective than having a strict divide by 2 circuit. But this is an extremely effective way of gaining energy from the local environment. The toroid is very effective, but should there be a runaway, then, as I've said, the excess power produced is fed to the electrolyzer, and that absorbs it and just makes more HHO gas, which is what we're trying to do anyway. So the electrolyzer is definitely both a load and a safety device. Now, the thing you need to understand is that there's a difference between DC electrolysis and resonant pulse DC electrolysis. With DC on its own, the bubbles form on the plates, and that's one of the reasons why you treat the plates and sand them so that you get little peaks. The little peaks help gas bubbles form and disconnect from the plate. The more advanced forms of electrolysis produce bubbles which form in the electrolyte between the plates rather than on the plates. Now those um, bubbles, which tend to be somewhat larger, are known as charged water clusters, and they're more highly energetic than general HHO bubbles are. The large cells made by Bob Boyce have the problem of getting replacement water into the many separate cells, but to a greater degree of getting the gas out of the electrolyzer because the volumes are just so high. Feeding replacement water into the cells is achieved by using a supply pipe which has a hole above every cell, while a gas extraction pipe has holes along the top. In this particular design, a piece of matting is placed across the entire set of plates, and the water drops coming down from the pipe land on the mat, seep through, and fill the cells individually. You get a sort of levelling out if the water supply is not particularly accurate, because one or more cells will then have less water in them than the main majority of the cells, and with less water in, less of the plate surface is covered, and as a result then less gas is produced, less water is used, and there tends to be a levelling off of the water levels. You'll notice in this that there is a large amount of space left on the plates, and that's because the amount of gas coming off is so energetic that the electrolyte splashes up and covers these plates pretty fully, the way that they're set at the moment. You'll also notice that the electrical connections come in underneath the surface of the electrolyte. Now that's a safety feature in that if there's any problem with any part of these connections, there will not be a spark produced. The disconnection will occur underneath the surface of the electrolyte, so there won't be a spark to ignite the gas that gets filled up into this area here. So that in itself is another practical application that wouldn't be immediately obvious to people. Now, as we've already mentioned, it is perfectly possible to run an ordinary commercial generator without the use of any conventional fuel. The way that this is done is fairly straightforward, and it's definitely easy to understand. What you do is you have a generator which has a motor inside it and an alternator. The alternator generally has a 12-volt output and mains output. The mains is AC, the 12-volt is DC. Now we use the 12-volt output to power the electrolyzer, which produces the gas, which is fed through a pipe into the incoming air going into the motor. Now, as we get an implosion when we ignite HHO, we want to put water droplets into that incoming airflow as well. It's a very effective system to do it that way. The cold water mist is a stream of tiny water droplets. Now those can be produced using a commercial pond fogger, which you can buy in a pet shop or a garden centre, or just very simply with a Venturi tube as shown in this particular diagram. Now you can make your own Venturi tube quite readily. What you do is you take a piece of copper pipe, give it a bend so that when you insert it in the incoming air tube it's pointing towards the motor. You then fill one end with a silver solder plug, and you drill a very small diameter hole through the plug, and finally you file down the outside so that you get a pointed exit, and that pointed exit causes the airflow around it to drag small droplets of liquid out into the airstream. Obviously we need some more safety features which I haven't mentioned so far. They are primarily one or two, preferably two, bubblers. In this particular design, tank is used to store some additional HHO, it has itself got a 10 pounds per square inch release valve, so if the pressure in the tank builds up too much, the gas is just released through the valve out into the open air. But the system is straightforward. You have a 12 volt supply powering the electrolyzer. The electrolyzer disconnects itself if the gas pressure inside rises above 10 pounds per square inch, and that is an effective way of ensuring that the HHO coming off the electrolyte doesn't spontaneously ignite. We don't want that to happen inside the electrolyzer. It's generally not a good idea. The rest of the system is exactly as shown before, and it's straightforward. Now, the thing is that we would like also to add a couple of extra safety features, especially if it's a stationary generator, which is the most common way, because running a generator like this generates kilowatts of excess power, and so tends to be used as a supply of power to a household. So what you do is you supply water to the system through a water main, which is controlled by an ordinary float valve like used in a toilet. That gives a water supply which is always there, and that water supply comes round and feeds into a water pump. The water pump is controlled by sensors inside the electrolyzer, which detect the level of electrolyte inside, and when necessary the water pump pumps water through a one-way valve into the electrolyzer. As the system may be switched off for some time, there is a starting battery. The starting battery is switched in initially when you're about to start the generator, and that builds up pressure in the electrolyzer, and when you're ready to go, you switch the electrical power back from the starting battery to the generator output. We also have one-way valves installed between each of the main components here. That's between the electrolyzer and the first bubbler, between the first bubbler and the tank, between the tank and the second bubbler, and Bob Boyce generally recommends that you should use a particle filter on the final flow of the gas before it goes into the ingoing air to the motor. Now, you have two options here. One of them is that you can put, instead of water, you can put acetone into the second of these bubblers, and that will mean that you don't have to change the timing of the spark used in the motor of the generator. Now, this is a well-known and well-liked method of making HHO gas, but there are other ways. One of them was demonstrated by Stanley Mayer of America. He avoided giving the full details of his design, even though it was shown on the TV documentary entitled "It Runs on Water." Nobody managed to copy Stan's system until Dave Lawton of Wales decided to replicate it. Dave tried for a full month without any success, and then suddenly Dave's cell burst into life, showing that a vital omitted detail that Stan didn't mention in the TV documentary is the fact that the electrodes need to be insulated. This water splitting cell uses pairs of tubular electrodes. One tube is placed inside the other, and the relative diameters determine the gap between the two electrodes in any electrode pair. Stanley Mayer used 15-inch, that's 300 millimeter long, tubes of stainless steel, which he misleadingly described as alloy tubes. And yes, it technically is true that stainless steel is an alloy. It's an alloy of chromium and carbon and steel and iron. Dave used copper pipes of only 6 inches in length because he was testing the principles. Stan Mayer used tap water. However, unfortunately, what most people don't seem to know is that tap water is completely different from place to place around the world, as it depends on the local geology and the treatment methods used by the supplier. And you get a vast range of different things dissolved in the water that's provided through the tap. Dave Lawton uses spring water. The method of construction used by Dave is this. He has an outside acrylic tube that you can see through because it's nice to see what's happening inside the electrolyzer, and for each pair of electrodes, and he has I think 6 from memory, there is a smaller diameter inner pipe or tube which has a stainless steel wire bolted to it and connected then to the external power supply. The other side of the power supply is connected through the case and a stainless steel wire to a stainless steel bolt which is attached to the outer pipe. Now that's a practical method of construction, but it's somewhat different from the method used by Stan Mayer, who welded the outside pipes to an arm coming off the base plate. And that's an interesting technique. And the inner pipes then are all supported on a second plate. So they're all interconnected by the physical construction without any extra wire or anything like that being used. The system shown here is how he actually did it. He also used a slot in the outer pipe to control the resonant frequency of that pipe. This is a technique that's used by German manufacturers of church organs. It's a very effective way of changing the resonant frequency of a pipe. This is a neat way of adjusting things, but don't run away with the idea that the resonance of the pipes themselves are the key feature. They aren't. The resonance that you need to hit with a system like this is the resonance of the cell as a whole. The cell resonance changes with temperature, and it changes with variations in water level. The challenge then that we have is to find and hold the resonant frequency, especially since the resonant frequency is a very narrow band of frequencies, and so the driving frequency needs to be controlled accurately. Dave drove his cell various different ways, with 3-phase supplies and single-phase supplies and so on. Initially he used a very simple set of pulsing circuits to achieve reasonable operation, but the ideal is a phase lock loop circuit which will find and lock onto the resonant frequency and stay on it no matter what happens inside the cell itself. Stan Mayer produced one of these circuits, but he kept the details confidential. He produced a patent, but the patent merely shows boxes which describe the function of the circuit inside the box, which may be okay for people who are experts in electronics, but it doesn't help the average person much at all. Dave Lawton also built and tested such a circuit, but he published the details. Now, starting with the manual circuitry, this is Dave's circuit, and he uses a drive coil here which is connected as a bifilar. He winds 2 100 turn 22 gauge enamel copper wire turns around a 3/8 inch or 10 millimeter ferrite rod, and this is the way that they are connected, the windings are connected to the actual tubes, inside tubes and outside tubes. And you want to pay attention to that if you ever reconstruct one of these, because that is important, the way that it's done. a very high quality FET diode is used to drive this system. It's a professional level BUZ350 transistor, and it is very sharp switching and very effective as a transistor. It's driven by two separate circuits. One is a simple 555 circuit of the frequency that you want to generate, and then you have the option, if you wish, to switch in a gating circuit which will allow or block the waveform going out to the final transistor. Now that's the simple manual system, but this circuit here is Dave's phase lock loop circuit, and if you're a hot shot electronics person, you will be able to build that yourself and understand it quite readily. Now, as well as Dave Lawton, Dr. Scott Crampton also worked using that style of water splitter construction. He used the same sort of cylindrical container for the system. That's a pipe with a plastic cap top and bottom, and he used his pipes which are held in position by a plastic ring or a plastic disc which has holes drilled in it. The inside and outside tubes are positioned carefully using nylon screws which are tapped into the outer pipe. The inner pipes are individually supported, quite separate from the outside pipes, on a Z-shaped piece of steel, which holds them in place as well as supplying the electric supply through the case to each of the inner electrode pipes. This is an effective way of doing things. Those Z-shaped brackets are an interesting way of supporting the inner pipes. Now, the outer pipes are connected in groups of 3 using pipe clamps, or known sometimes as Jubilee clips or Bulldog clips. And he used a 3-phase supply, so he has 1, 2, 3 pipes connected to one supply, 1, 2, 3 pipes connected to the second supply, and 1, 2, 3 pipes connected to the third phase of his electrical supply. Now the inner pipes, as we said before, are positioned carefully using what are effectively grub screws. Now these are plastic screws, so that there's no electrical connection between the inner and outer pipe. And there are 2 sets, one at the bottom and one at the top of the pipes. The pipes he's using are 18 inches tall, which is a sensible idea, because the taller the pipes, the greater the surface area, and the greater the surface area, the larger the amount of HHO produced by the operation. He also found that you needed to match the resonant frequencies of the pipes within 10 cycles per second of each other. Now that sounds like a lot, but it isn't really, because you're talking about 5 cycles a second in 22,000 cycles. So that's like 1 in 4,000. So that's a pretty high degree of accuracy. The way that he used to determine the frequencies was to suspend the components on a thread and then strike them to determine their resonant frequencies, which he measured with a meter. So you suspend the components along with their connection parts and then tap them to get the resonant frequency. Now Dr. Crampton has stated that he can reduce the diesel requirement of any diesel engine of any capacity by 60% through the adding of HHO gas. Now, to make sure that you understand that, it reduces 10 gallons of fuel required to 4 gallons of fuel required, and that's impressive for a diesel engine. Now, Bob Boyce's toroid cell, Dave Lawton's water splitter cell, Dr. Crampton's water splitter cell are all high-tech systems. They're good working systems, and good working systems can also be made without getting involved in any kind of advanced technology. For example, let's talk about the system used by Zach West of America. Zach ran a 250cc motorcycle on public roads using just HHO as the fuel. I suppose that, loosely speaking, you could describe his motorcycle as running on water alone, although that's not strictly speaking true, even though it looks like it. He performs electrolysis of water using his own home-built electrolyzer. He then bleeds off most of the oxygen, making the gas far less volatile, and he stores some of that in a tank ready for increases in load, such as accelerating away from traffic lights. His system is like this. You have a water container with an airtight cap. That supplies water to the 8 electrolyzer cells that he uses. Those electrolyzer cells are powered by a 6-volt battery from his motorcycle. The electronics board is very simple, it's just a DC pulsar, and when that DC pulsed electricity is fed to his cells, it is passed through an electromagnet. The electromagnet has a steel core. Now, this electromagnet is on the outside of his tall bubbler, and he uses the bubbler as a gas separator. There is a partition that comes down below the surface of the electrolyte, and because HHO comprises mainly hydrogen atoms which are positively charged and oxygen atoms which are negatively charged, having this magnetic field across the bubbler tends to push the oxygen to the right and the hydrogen to the left. The hydrogen goes on out to the storage tank, which is allowed to build up to 30 pounds per square inch, because it's no longer as reactive as the HHO gas coming out of his electrolyzers. And the mainly oxygen that comes out on the other side is vented out to the open air, and the output from the tank goes through a normal standard throttle and on to the motorcycle. Zach's electrolysis is carried out in a series of these individual units. They're 10 inches high, they have a gas vent in the cap at the top, they have a water supply pipe which comes down to the to the surface of the electrolyte, and that, when the electrolyte surface drops, the outside air pressure of the system, well, it's working on the surface of the earth, so there's about 14 pounds a square inch of air pressure outside everywhere. That controls the flow of water into each cell, because when the electrolyte level comes up past the bottom of the pipe, the outside air pressure stops any more coming in. The electrolysis plates are wound round in circles. He's using very thin steel shim stock, which is easy to bend. It's springy, and so it can be wound round if you're determined, and he uses spacers between the 2 sheets that he uses for his electrodes, and his electrodes are only 5 inches tall inside this particular cell, and they're connected separately, one to the positive and the other to the negative. And this is a very simple style of construction, and it works very well. He connects his electrolyzer cells together in pairs. Now they're just connected in parallel, with the pluses connected together and the minuses connected together. So there's nothing fancy about this. Now those pairs that he has connected are then connected in series, plus to minus, plus to minus, plus to minus, to form 4 paralleled pairs of units inside his overall casing. Now that is an effective way of doing it. He uses a 30 amp DC motor speed controller circuit, which is commercially bought. His particular unit looks like this. This is the unit he was using, I believe. It's a small circuit board which has a transistor mounted on a large heatsink and a variable resistor which allows you to adjust the speed of the pulses. His gas reservoir is homemade. It's made from a 4-inch or 100mm PVC pipe with PVC end caps glued in place to make them completely airtight and immovable. And the pipe coming in and going out, those 2 pipes are 10mm diameter or 3/8 inch, and they're also glued in place to form a secure, solid and very airtight storage tank. That storage tank is mounted on and used as part of the motorcycle. But in overall principle, it's basically very simple. You have a water supply which feeds 4 pairs of electrolyzer cells. The electrolyzer is contained in an airtight plastic box, and the output from that is fed through a pipe down to the bottom of an electrolyzer and comes out then as bubbles which float up through the water inside the electrolyzer. And his north-south magnetic field across the electrolyzer tends to push the oxygen to the right, the hydrogen to the left, and the hydrogen is taken off for use. There's a silicon divider to separate the air above, or the gas mix above, the water surface, and the predominantly oxygen that comes off on the right goes through a one-way valve and is vented out to the open air. He uses a very tall bubbler system, which is 14 inches tall. This system can power a motorcycle, but in my opinion it's probably not self-powered, because motorcycle electric systems are generally very low performance, and it's unlikely that one will be able to sustain the lights at night time and the electrolysis system. But if you were to add an additional battery which you charge using a solar panel, you can then make the motorcycle effectively a solar powered vehicle and essentially fuelless in operation. Now that's interesting as it stands, but Charles Garrett, back in 1935, which is 80 years ago, used a design of his to run his car on water alone. Cars in 1935 were very much lighter. They had much smaller engines and had 6-volt electrical systems. Now this is his particular electrolyzer, which is quite cunning. As it's a 6-volt system, he has got 1, 2, 3, 4 areas of electrolysis. So with 6 volts applied across it, you have 1.5 volts across each cell, which is a good voltage to apply to the plates of a cell. Now the air in this system comes in through here, and it goes out through the air intake here, through a flap, a one-way valve flap, and down along this pipe and comes out in little bubbles through holes underneath each of these 4 electrolysis sections. So what you get coming off this electrolyte is a mixture of air, water vapor and HHO gas, and that goes through a flap valve and is fed out to the engine through the throttle of the engine itself. This is a very slick system, and to boost the way that it operated, Charles added a second 6-volt alternator to his car. He also used a changeover switch from time to time to connect the electrical power to the opposite electrode plates, but this was just to even what he considered to be the wear of the plates. His electrolyte was just a few drops of hydrochloric acid in water. The air entering the engine is passed between the electrode plates in order to dislodge the HHO bubbles as much as anything. But what it does is it feeds the engine air plus HHO plus water vapor. He used a float and a needle valve arrangement to feed extra water into the engine when it was needed. The float would get pressed up and cut off the water supply, but when the float via the weights here is pressed down, extra water is fed into the electrolyte. This is a very effective system, and it worked well on his vehicle. 50 years after Charles Garrett, Archie Blue produced a fairly similar electrolyzer, which he claimed ran his car. The construction is fairly simple, and like Charles Garrett's electrolyzer, Archie draws air through the unit on its way to the engine, again feeding air plus HHO plus water vapor to the engine. The electrolysis cell that he produced looks like this. It is a circular housing, cylindrical circular housing, with a cap top and bottom, and the electrode plates are circular and have holes drilled in them. Now, the central hole here has a pipe which is insulated, as shown in green, running down through each electrode. Now, in 1985, you're talking about 12-volt cars, and the number of electrolysis areas inside this cell are 1, 2, 3, 4, 5, 6, 7. So with this 12 volts, Archie Blue has opted to have 7 electrolysis areas. Now that's an effective way to do it. And he uses an air pump. The air pump pushes air down through the central tube to an air hole. The bottom of the tube is blanked off. The air hole lets the air out, and there's a deflector here that pushes the air up through the first electrode plate. The buoyancy of the bubbles that are pushed through helps them move on upwards through the system, and this is an effective way of doing it. There is an anti-splash baffle protecting the output gas pipe, and Archie opted to use more than one of these. Now, what you need to understand is that each of these are connected across the 12-volt electrical supply, and while they're all connected that way, they're not connected in gas output that way. Each of these cells has 12 volts across it. The air is pumped in by an air pump, and the air pump pushes the air down into the first electrolyzer. Due to the electrolysis, the air is mixed with HHO when it comes out and goes down into the second cell, and it gets mixed with HHO generated in that cell and comes out as a stronger mixture of HHO and air, and so on down each of these cells. So what comes out and heads to the car is a gas mix which is very strong in HHO, but it also has water vapor in it, and it has air in it, obviously. That arrangement gives progressively stronger HHO gas with every cell that you add into the system, as well as producing a larger volume of gas. In 2017, the UK government states that new petrol and or diesel engine cars will be prohibited in a few years' time. However, using a booster, which is a simple electrolyzer, cuts harmful emissions from any vehicle engine, cuts them to nearly zero, and it increases the miles per gallon produced by any engine. One design of booster which has worked very well indeed with American cars, which have 5-litre capacity engines and terribly low miles per gallon figures. The designer of this booster got a 50% increase in miles per gallon on his 5-litre 1992 Chevy Caprice, going from 18 miles per gallon to 27 miles per gallon. Now that sounds horrible to us. I had a 2-litre Renault 25 which would cruise comfortably at 120 miles an hour, and I got 44 miles per gallon from that particular vehicle in all kinds of driving, from round city and on open roads. Now admittedly, the American gallon is 20% smaller than the gallon everywhere else, so the difference is not quite as large as it seems, but it is a major difference. However, what you need to understand is that if your car is giving you 18 miles a gallon and you have to fill the tank, you're going to do filling the tank a lot less often if you're getting 27 miles per gallon. The current flow through this style of booster is controlled by using an electrolyte which has less catalyst in it. The main unit looks like this. It's pretty neat construction, nicely done wire connections, and a meter to show how much is being consumed in the way of electrical current, though admittedly consumed is not the right word. Drawn through the meter would be a better description. Now let me warn you again, this is not a toy. If you make and use one of these, you do so entirely at your own risk. Neither the designer of the booster, the author of this document, or the provider of the internet display are in any way liable should you suffer any loss or damage through your own actions. While it's believed to be entirely safe to make and use a booster of this design, provided that the safety instructions shown below are followed, it's stressed that the responsibility is yours and yours alone. Right, this booster draws 15 amps when it's in use. The electrolyte is 1 teaspoon of sodium hydroxide in 8 litres of water. In America, this sodium hydroxide is sold as Red Devil lye in places like Home Depot. The body of the electrolyzer or booster is made from ABS plastic, which has a central stainless steel negative electrode, and the positive electrode is formed by winding stainless steel shim stock around the inside of the container. System is very straightforward. The battery feeds through to the central electrode. The positive line goes through a key switch and a relay, and then through a 30 amp circuit breaker, so that if there's any disastrous problem like a short circuit somewhere, the circuit itself will disconnect immediately. The HHO output is then passed through a steam trap, a bubbler and a water trap before being fed to the air intake. So you have the electrolyzer itself going through wire mesh is effectively acting as an anti-splash device. Remember, this is mounted in a car and the car goes over bumps, So you have to make sure that a electrolyte doesn't splash up into the outlet pipe. The outlet pipe comes through to a steam trap, which also has wire mesh at the top. It goes through a one-way valve into a safety bubbler. The safety bubbler itself also has wire mesh at the top. And the outgoing gas then passes through a water trap, which removes most of the moisture, leaving the final gas to go out to the engine air intake. Now, the ebook already mentioned, which is www.freeenergyinfo.com/pjkbook.pdf, has full constructional details in the appendix, including a parts list and many photographs. This is the shim stock being positioned round the inside of the cell itself and being bolted into place with a long reach a piece of equipment. When it's bolted and securely held, the cap that's used on the ABS pipe has a hole drilled in it, ready to take the electrical connection which goes through it. This is the negative supply electrode, and this is the finished unit with the electrical connection out the side and in and out through the top. The designer recommends that you use plumber's tape for any screw connections that you're making through which gas flows. And this is the style of mesh that he uses inside all of his units. Now, another very popular booster is known as the SMAX booster, because it was designed and built by a man whose ID on the internet is the SMAC. It's a compact unit and it's very effective. It's expected to give at least 20% improvement in miles per gallon, as well as cutting harmful emissions drastically. And this is what it looks like. You have a plastic tube with caps top and bottom, a screw-in lid, which is the top cap, and electrical connections are made through the cap to a set of plates. Now there are 8 pairs of plates here, and they're made from readily available wall socket covers in the States. The electrodes are cheap, but they can also be constructed from 316L grade stainless steel. The body, the bubbler and the tubes are all plastic. A nice feature of the bubbler is that it's attached to the booster itself and it's see-through, so you can easily judge the performance of your booster by looking at the size and rate of the bubbles rising through the bubbler. The connecting straps that you use for the electrical circuit are made of brass. The SMAC prefers to cut them from tableware, but it's quite readily easy to get strips of plastic or strips of brass or plates of brass from which you can cut strips. The connecting bolts used are plastic, so that they don't carry an electrical current. The plates are put together and drilled all in one go, and then they're cross-sanded carefully, and this is what they look like after sanding. Or if you prefer, instead of sanding them, you can dent them using a metallic punch. The metallic punch will give you dimples on the plates and increase the surface of the plate area, which you can then just sand gently to get a good electrical connection to it. The way that the electrical connections are made through the cap is very effective. You have the bolt clamped to the strap, which can be either brass or stainless steel, and then a washer is used each side of the bolt hole through the plastic cap, and then the electrical connector is clamped on using two nuts, and a lock nut is then used to make sure that the top nut doesn't work loose with vibration. The way that the plates are connected is interesting. The positive supply comes down through the outside plate and through an electrical strap to the outside plate on the other side. The negative connection comes through two metal nuts and connects to the two inside plates. The yellow gaps are plastic washers which prevents the plates from short-circuiting between each other. So effectively you've got 4 pairs here and 4 pairs there. The reason for that is because although some of these things are insulated, the plates are then dumped into a single body of electrolyte. Now this is not helpful, and to make it work properly you need to give it more than 1.24 volts per electrolysis cell. You must remember that if you're going to dump the plates into one body of electrolyte, then electricity can flow through the electrolyte from the minus directly to the plus. This plate is connected to the plus, this plate is connected to the minus, and there's nothing blocking the flow between them. So it's not that easy to persuade the electricity to flow through the middle plates, which we need to happen for electrolysis to occur. In theory you get 3 volts across each pair of plates if you apply 12 volts across them. Life isn't as nice as that, unfortunately, because they're not in separate bodies of electrolyte. If they were in separate bodies of electrolyte, then it would be fine, but they aren't in this case. But you can improve it to a certain degree by insulating round the entire set of plates by using either tape or shrink wrap. Now the problem, of course, is that the plates have to be open at one side to a body of electrolyte. First, to let the gas bubbles out, and secondly, to let electrolyte in. So unfortunately we have a problem in that the electrolyte is connected vertically over the plates to the next body of electrolyte, and then over the plates to the same body. It's one body of electrolyte, and that does create a problem as such. The electrolyte itself is distilled water with either sodium hydroxide or potassium hydroxide mixed into it in sufficient concentration to get an overall current flow of 20 amps. Now it's a little difficult to visualize, so you can see here from the red that's where the positive line runs, and from the blue where the negative line runs, and you've 10 amps going from this negative line to this positive line, and 10 amps going from this negative line to this positive line. Now they combine obviously so that you get 20 amps going in and out through the two straps which connect it to the battery. Now in case these notes might be useful, you can get them as a free download from the same www.freeenergyinfo.com, this time using the name of the file as capital HHO.pdf.